Hello students, in this video lecture we will solve test number 1 completely with its model answers. This test was conducted on 15th March 2023 of the subject theory of machines. First question was define mechanism and machine. So let us define mechanism. Mechanism is defined as a combination of resistant body that are shaped and connected in such a way that they move with definite relative motion with respect to each other. A mechanism is a mean of transmitting, controlling or constraining relative movement. Mechanism is rigid body connected together by a joint. The term mechanism is applied to the combination of geometrical bodies which constitute a machine or a part of machine. In this way we can define mechanism. Let us define what is machine. A machine is a combination of resistant body with successfully constrained relative motions which is used for transmitting other forms of energy into mechanical energy or transmitting and modifying available energy to do some particular kind of work. Machine consists of number of kinematically related links. A machine is a combination of components which can transmit power in a controlled manner and which is capable of performing useful work. Examples of machines are heat engine, electric power, electric motor and a pump. Heat engine receives heat energy and transfers it into mechanical energy. Electric motor changes electrical energy into mechanical energy, while for a pump input is electric power and output is hydraulic power. Question 1b was draw sketches of number 1 is higher pair and number 2 is sliding pair. So here we have to draw only sketches, but before that let us understand what is pair. Pair is a joint of two links that permits relative motion. When any two links are connected in such a way that their relative motion is completely or successfully constrained, they form a kinematic pair. So this is a sketch of a kinematic pair in which you will see that two kinematic links are connected with the help of kinematic joint. So how is the sketch of this higher pair? You will see that if a kinematic pair in motion has a line or point contact between the two links, it is called higher pair. For example, cam and follower. So cam and follower is the representation of higher pair. How to represent sliding pair? When two links have a sliding motions relative to each other, it is known as sliding or prismatic pair. Example is piston and a cylinder. Here you will see in this sketch a rectangular block is going to slide inside a fixed rectangular slot. Question number 1c was state the use of pendulum pump and quick return mechanism. So pendulum pump is also called as a bull engine mechanism. The mechanism is used in duplex pump in boilers and also in manual hand pumps fitted on the bore well. So here is a sketch of in front of you the pendulum pump, and here the practical figure that you can see on the right hand side. What are the applications of quick return mechanism? A quick return speed mechanism is used in shaper and slaughter machine, in which the circular motion is converted to reciprocating motion so that the slider moves forward and backward. In the forward direction, the cutting process occurs when there is no such cutting, whereas there is no such cutting in return stroke. There are three types of quick return mechanisms. Number 1 is crank and slotted link mechanism, number 2 is Whitworth mechanism, and number 3 is hydraulic drive. Question 1 number 1D was define kinematic pair and kinematic link. So kinematic pair, as I already defined previously in the previous slide. So let us define again. When two links are connected in such a manner that relative motion between them takes place in a definite way, then it is called kinematic pair. What is kinematic link or kinematic element? It is defined as a resistant body which has relative motion with some other element. Examples of kinematic links are crank, piston, cylinder, frame. So here in this sketch you will see the representation of kinematic link: binary link, ternary link, quaternary link. These are the some of the types of kinematic links. Question number 1E is define completely constant motion and successfully constant motion. Let us first define completely constant motion. When the motion between a pair can take place in one and only one direction or in one and only one way, then it is said to be completely constant motion. The example of completely constant motion is rectangular shaft revolving a rectangular hole. Define partially or successfully constant motion. When the constant motion between a pair is not completed by itself but by some other means, it is said to be partially constant motion or successfully constant motion. The motion of a shaft in a footstep bearing is an example of successfully constant motion when compressive load is applied to the shaft. Question number 1F, state the 4 applications of cam and follower. Let us see what are the applications. Applications of cam follower are: number 1 is operating the inlet and exhaust valves of internal combustion engines. It is used in automatic attachments of machineries, paper cutting machines, used in spinning and weaving textile machineries, used in feed mechanism of automatic lathe, used in diesel fuel pumps. They are also used in printing control mechanisms. They are also found in wall clock and feed mechanism of automatic lathe. So here you will see the application of cam and follower in internal combustion engine in opening and closing of the valve. So here you will see the cam at the top and a follower. To the follower a valve is attached which is having a spring connection between it. Sketch and explain the quick return mechanism, any one. So there are two types of quick return mechanism. Number 1 is crank and slotted lever mechanism for shaper, and second one is Whitworth quick return mechanism. So in this sketch I am explaining both of the mechanism. First is quick return mechanism for shaper. So in this quick return mechanism or crank and slotted lever mechanism which is used in shaping machines, slotting machines, and in rotary internal combustion engines. In this you will see that the link AC, that is link number 3, forming the turning pair is fixed. The link 3 corresponds to connecting rod of the reciprocating steam engine. How it works? The driving crank CB revolves with the uniform angular speed about the fixed center C, as you can see in this picture. A sliding block attached to the crank pin at point B slides along the slotted bar AP and thus causes AP to oscillate about the pivoted point A. A short link PR transmits the motion from AP to the ram which carries the tool and reciprocates along the line of stroke R1 R2. The line of stroke of the ram is perpendicular to AC. The extreme positions AP1 and AP2 are tangential to the circle and the cutting tool is at the end of the stroke. The forward or cutting stroke occurs when the crank rotates from the position CB1 to CB2 through an angle beta in a clockwise direction. The return stroke occurs when the crank rotates from the position CB2 to CB1 or through an angle alpha in the clockwise direction. In this way we can define time of cutting stroke is beta and time of return stroke is alpha. So beta upon 360 minus beta is nothing but the required ratio. Second mechanism you will see in this figure is a Whitworth quick return mechanism. In this mechanism you will see that the link CD, link number 2 forming the turning pair is fixed. The link number 2 corresponds to crank in a reciprocating steam engine. The driving crank CA, that is link number 3, rotates at a uniform angular speed. The slider 4 attached to the crank pin at the slide along with the slotted bar PA, that is link number 1, which oscillates at the pivoted point D. The connecting rod PR carries the ram at R to which a cutting tool is fixed. The motion of the tool is constrained along the line RD produced, that is along a line passing through D and perpendicular to CD. How it works? When the driving crank CA moves from the position CA1 to CA2 through an angle alpha in the clockwise direction, the tool moves from the left hand end of its stroke to the right hand end through a distance PD. Now when the driving crank moves from the position CA2 to CA1 through an angle beta in the clockwise direction, the tool moves back from the right hand end of its stroke to the left hand end. Question number 2b is explain detailed classification of the follower. In this picture you will see there are 6 types of follower. You will see oscillating or rotating follower, number 1. Number 2 is translating or reciprocating follower. Number 3 is knife edge follower. Number 4 is roller follower, flat faced or mushroom follower, and last one is a spherical faced follower. All these are represented in this figure. Question number 2c was differentiate between machine and structure. So machine transfers the available energy into useful work, while structure does not transfer any kind of available energy into the work done. The parts of machine move relative to one another, while the parts of structure do not move relative to one another. Links of a machine may transmit both power and motion, while the members of the structure are meant for carrying the load only. Examples of machines are lathe machine and other machine tools in workshop, while the example of structures are railway bridge, building. These are some of the examples. Question number 2d was state complete classification of inversion of kinematic chain. It is classified into 3 categories. Number 1 is 4-bar chain, which is also called quadric cycle chain. This 4-bar chain is divided into 3 parts: crank and lever mechanism, beam engine, and pantograph. Second classification of or inversion of kinematic chain is single slider crank chain. It is further having 4 parts, 4 classifications. Rotary engine mechanism is the first. Number 2 is oscillating cylinder engine mechanism. Number 3 is quick return mechanism, and number 4 is pendulum pump. So quick return mechanism are also of 2 types. Number 1 is crank and slotted lever mechanism, and number 2 is Whitworth quick return mechanism. Kinematic chain is also classified into 3rd category, double slider crank chain mechanism. It has 3 mechanisms. Number 1 is elliptical trammel, number 2 is Scotch yoke mechanism, and number 3 is Oldham's coupling. Question number 2e was draw the sketch of 4-bar chain and single slider crank chain for the 4 marks. So here you will see the 4-bar chain, in which you will see frame is fixed. So this chain has 4 links and it looks like a cycle frame, and hence it is called quadric cycle chain. It is shown in the figure. In this type of chain all 4 pairs will be a turning pair. And second figure is of single slider crank chain, in which you will see the single slider crank chain is a modification of basic 4-bar chain. It consists of 1 sliding pair and 3 turning pairs. It is usually found in reciprocating steam engine mechanism. This type of mechanism converts rotary motion into reciprocating motion or vice versa. In this way we have solved this test number 1. Thank you.